Properties of rational exponents and radicals. We're on example 3, writing radicals in simplest form. So write the expression in simplest form. A part says we have cube root of 135. So we know that we have to have something to the cube power to undo the cube root. Remember, the cube root is equal to the 1/3 power. So 135, we need to somehow rewrite that. And so you have to know your perfect cubes. So if you don't know those by heart, I have these listed here, something you may want to put in your notes just till you get more familiar with these. But 2 cubed is 8, 3 cubed is 27, 4 cubed 64, 5 cubed is 125, and 6 cubed is 216. Those are pretty common. You'll see those a lot. So just being familiar with those may help you down the road. But anyways, none of those, if you look down this list, 135 is not on here. So what we're going to have to do is rewrite this in a different form. So first thing, let's go ahead and take our calculator and let's do some calculations here. So what we're trying to do is see which of these perfect cubes goes evenly into 135. So we're just rewriting 135 as a product of two things. So let's try 8 first. So 135 divided by 8 does not go evenly. So we're going to do 135 divided by our next perfect cube is 27. 27 is 3 cubed. And that one does go into 135 evenly. So we can rewrite this as cube root of, and then again we're just rewriting it, so we're going to have a product of two numbers. So 27 times 5. So you can see that 27 went into 135 5 times. So you can see that 27 times 5 equals 135. Okay, and 27, again, the reason we chose that is because it is a perfect cube. 3 cubed is 27. So we can rewrite this as cube root of 27 times the cube root of 5. The cube root of 27 again is 3 times the cube root of 5. So that would be in simplest form. All right, B part says the 5th root of 7 over the 5th root of 8. Well, 7's a prime number. 8's not prime, but there's not many things that go into it. So it's 2 cubed, or it's 2 times 4, which again is just another version of 2 cubed. But 2 cubed, 2 is a prime number, so 2 to the 3rd power, and we need something to the 5th power. So for this example, we're going to have to rationalize the denominator, which means we have to get the radical out of the denominator. So to do that, we have to have something to a 5th power down at the bottom. So since this is 2 cubed, we need 2 squared. 2 cubed times 2 squared is going to be a 5th power. Remember, the 5th root is the same as something to the 1/5 power. So that would cancel. So and I know that 2 squared is 4, so I need 4. And this has to be a version of 1. If you remember in your vocabulary terms, you're always multiplying by some version of 1, which means you're multiplying by something over itself. If you multiply something over itself, anything divided by itself is 1. And right now we're just trying to manipulate the denominator so that it's no longer a radical. The numerator can be a radical, but the denominator cannot be a radical, or it's not considered simplest form. All right, so now we have, and start on the bottom because that's where we started here. So the 5th root of, and then 8 times 4 is 32. And again, remember 32 is 2 to the 5th power, which is what we need here. And then on top, you've got the 5th root of 7 times the 5th root of 4. So we're going to have the 5th root of And that's going to be 28. 7 times 4. All right, so we can rewrite that as the 5th root of 28 over, and again, the 5th root of 32 is just 2. So that's going to be simplified. If you want to check that using the calculator, again, you can do that. So if we slide this over here, and you can go 5th root, math, go to the x root, number 5, and then 32. And you can see that that does simplify down to 2. So that right here goes to 2. Now, 28 is 4 times 7. 7 is 3. 7 is just 7, but 4 is 2 times 2. There's nothing that can be broken down here in order to pull anything out of your 5th root. So this will just stay 5th root of 28 divided by 2. Example 4, writing a radical expression in simplest form. So example 4 is 1 divided by 5 plus the square root of 3. So we can see that this is a binomial. So if we want to rationalize the denominator, in this case, we have two things that are joined together and we can't separate those. So if we multiplied the top and the bottom just by square root of 3, we would have to distribute that to each thing in the denominator, which means we would have 5 square root of 3 plus square root of 3 squared, which would just be 3. So even though we would get rid of the radical in the second part, we would have added it to the first part. So there is something called conjugates. So two binomials of the form square root of a plus square root of b and square root of a minus square root of b are called conjugate radicals. Okay, so both parts do not have to be a square root. You can see here an example. The conjugate of 2 minus the square root of 3 is 2 plus the square root of 3. So same binomial, different sign in the middle. To me, this reminds me of a difference of squares. Same binomial, different sign in the middle, and the middle term cancels out. So with this being said, to simplify number 4, we have to multiply by the conjugate of 5 plus the square root of 3. So the conjugate of 5 plus the square root of 3 is going to be 5 minus the square root of 3. And we do have to multiply both the numerator and the denominator by that. And remember, as stated before, anything divided by itself is equivalent to 1. So we're essentially multiplying this expression by 1, just a different version of 1. So we're not changing the problem, we're just kind of manipulating it to make it look different. We're trying to get the radical out of the denominator. All right, so now we have 1 times, and we're going to multiply this by the numerator. So 1 times what's on the numerator is still going to be 5 minus square root of 3, because 1 times anything is just itself, right? And then on the bottom, we have two binomials, so you have to do distributive property, or some people call it FOIL. So 5 times 5 is 25. 5 times the negative square root of 3 is negative 5 square roots of 3. And then the square root of 3 times 5 is positive square root of 3. So again, the middle terms cancel. I'm not going to write those down. And then I have plus square root of 3 and minus square root of 3. So plus and minus multiplied is negative. The square root of 3 squared is just 3. So we're going to have 5 minus the square root of 3. And then 25 minus 3 is just 22. So this is simplified because there's no longer a radical in the denominator. Example 5. Adding and subtracting like radicals and roots. Simplify each expression. All right, so like radicals are the same index and the same radicand. So if they have the same numbers here, 4th root of 10, 4th root of 10, then we can add or subtract them like terms. So this one does not have a coefficient, so we assume that to be a 1. So you can write that down so you don't forget. And then we have 1 plus 7. So basically we're just adding those together, and we get 8 4th roots of 10. And that would be simplified. In B part, we can see that we have 2 times 8 to the 5th or 1/5 power plus 10 times 8 to the 1/5 power. Both of these are 8 to the 1/5 power. Think of that as like 2x plus 10x. It's not an x, but they are like radicals, in this case rational exponents. So all we do is add the coefficients and keep the variable, or in this case the like radicals, like rational exponents, the same. So 2 plus 10 is 12. And then again, we just keep 8 to the 1/5 power the same. So 8 to the 1/5 power. So you're just adding or subtracting like terms, basically. Like radicals are very similar to like terms. All right, C part's a little bit different. We've got the cube root of 54 minus the cube root of 2. So these they have like indexes, but the radicands are different. So first we're going to have to rewrite 54. So we'll just try to simplify 54. Remember our cube roots. 8, 27, 81, and so on. All right, so I do know that 27 times 2 is 54. And again, you may have to use your calculator, play with some numbers to see how to rewrite that. If you're good at multiplication, this will not be difficult. If you struggle with multiplication, then you're going to have to figure out a way to be able to rewrite these terms. So 54 is 27 times 2. And again, the reason we use 27 is because it's a perfect cube, and we're taking the cube root of this. So minus the cube root of 2. So we can separate this as the cube root of 27 times the cube root of 2 minus the cube root of 2. And again, the cube root of 27 is 3. And then we've got the cube root of 2 minus the cube root of 2. So we've got 3 times that cube root, and then minus 1. So 3 cube roots of 2 minus, again, if there's no coefficient, you assume it to be a 1. So basically 3 minus 1 is 2 cube roots of 2.